check with Jessica, Amy, Zisheng, Sophie. Let's turn on the camera. So we will start. So for the first question, okay, so this is from the um, American Mathematics Competitions, sort of AMC, American Mathematics Competitions. From last year, it's 10A. The first question, Andy and Bestie, they are at the same place. Andy leaves this place at 1:30 p.m. and runs north with 8 miles per hour. Bestie leaves the same point but at 2:30, traveling east with 12 miles per hour. At what time will they be at exact same distance from their common starting point?
4:30.
4:30. Okay, how do you get that?
Uh, because basically, um, after 2 hours, no, 3 hours for
Uh-huh.
Andy, it'll be 4:30, right? Because he left at 1:30. So you multiply 3 by it, and that's 24. And
Okay. Mhm.
2:30 to 4:30 is 2 hours, and 2 times 12, which is how fast Betsy is going, is 24. So they will,
Okay.
yeah.
Mhm. Okay. So if we know the answer is this, we can verify they are at the same distance at 4:30. Without knowing this, how did you check this one by one, or do you have an equation, Amy?
Um, I checked it. Well, actually, I started at the last one, actually, and it just so happens to be correct.
All right. Okay. Good. Okay. Okay. You have a very good luck.
It wasn't like a long process either, so I decided just to check them.
Okay. 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 Jessica, what do you think?
I agree with Amy.
No, that's not that's not enough. That's not enough. Okay, so here let's set up the formula for this. First one, he lives at 1:30 traveling north. I will go north at 8 miles per hour. The bestie, she goes east 12 miles per hour. Okay. At what time they will be exact the same distance? We don't know what it is. Let's assume the time we needed is x. So if we have x time, that's the speed. X times 8 will be the total distance traveled. 8x. But Bestie, she moved faster, but it started 1 hour late. So the time for Bestie will be x minus 1. Okay. Then they have the same distance. Same distance means 8x. Okay. So now we have an equation about the unknown traveling time. This will be traveling time. We can solve x from this equation. they will be at the same distance 3 hours later. So the time will be 4:30. So we use the information to set up an equation. We solve x, and we get the time, which will be e. That's what Amy checked. Okay, it works. Second one. Second one, a box contains 10 pounds of nut mix, 50% peanuts, 20% cashew, and 30% almond. A second unit containing different percentages, 20 peanuts, 40% cashew, and 40% almond is added to the box. Now we have a larger mixing, which is 40% of peanuts. We want to use this to find out how many pounds of cashew are now in the box. Okay, so where do we start?
So I actually had some trouble with this one. I wasn't able to solve this one. Um,
Uh-huh.
but I started by making an equation for the first 10 pounds of nut mix.
Okay, so what have you got?
Um, is it kind of like messy to put three variables in it?
What your feedback will be?
Well, X is the peanuts, Y is the cashews, and Z I put as the almonds.
Okay, this is for the first box, or the second
Uh,
box, or the
this
mix to.
is this is the first box. So I did 0.5x
Mhm.
plus 0.2y,
Okay, so let me see.
something like that.
So
Yeah.
here, 50% peanut. What does that mean?
One
That's
half.
five pounds.
Okay, so it means the peanuts will be of 5 pounds.
Yeah.
Okay, so if this is your peanuts, this will be 5. Is that what it means?
Mm-hmm.
Okay, so what's y?
Y would be
10 pounds, 20% cashew.
Two, I believe.
yeah.
Okay, it'll be 2. What
And
about z?
three.
3. Okay, so that's the first box. Second box, what's the weight of second box?
We don't know that.
Okay, unknown. Let's assume will be B, the
Yes.
box. I used X and Y, so let's see. Yeah. Okay, Jessica, the second box, this is the weight, unknown weight. Now we know it has 20% peanuts. So what's the amount of peanut in the second box?
2.
So the second mix is weight is unknown. We assume it's B.
Oh, okay. So
20% of this.
1/5 B,
So
right?
20%. Let me check what's going on. Okay. So this will peanut. Okay. So for clarity, I'm going to drop these variables and I will use P for peanuts. I will use cashew, C for cashew. First mix. I
Oh,
use,
that's what I did.
okay, nice. Okay. Then this is unknown. I'm going to
That's actually P, not R.
Which one?
Oh, wait, never mind, never mind.
Okay. So now the second mixing, P2, C2, A2. Okay, Aaron, what's the P2? The amount of peanuts in the second mixing.
Let's see now. You could say 0.2x, but I'll just say 1/5 x for 30.
Okay, that's 0.2 is fine.
And then 0.4x for C, and then 0.4 Z. I mean, yeah, 0.4x. Yeah, sorry.
Okay. Okay, now we're going to put the two mixings together. Then together, what's the total amount of peanuts?
0.4 parentheses x plus 10. Of course, parentheses.
So P. The peanut has two sources. The first mix and the second mix. What's the
Mhm.
total, Aaron?
Well, I was gonna say like yeah, but I'll just go with them. 5 plus 0.2x.
5 plus 2x. What's the total? Hmm. Okay, so the information we have, a new mix that is 40% peanuts. So we know the total peanuts. What's the total weight for the second mix? Amy.
Well, mm,
Okay, let me Amy try. Total.
Hold on. I'm still writing everything down.
Uh-huh.
Um, so do I just write it as an equation like
So here should be a formula. What's the total weight?
okay.
We have
Uh
box one, box two. What is
0, 1, wait, x plus
the first box?
the first box is 10 in
So
total.
it will total will be 10 plus x.
Yeah.
Okay, so then this total new mixing is 40% peanuts. We have the amount of peanuts, have the total. How do we get an equation for this?
5 plus 0.2x equals let's see, 2/5 parentheses 10 plus x.
Okay, so I will do that in two steps. Okay, then I will multiply both sides by 10 plus x. Okay, we simplify. So 1 equals 0.2x. X is,
Wait, isn't it negative 0.2x?
okay, so 0.4, 0.2, 0.2, 0.4. What's the if we subtract 0.2 from both sides, what do we get?
Well, 0.2, but you subtracted 4 from 5. Well,
So,
I guess that works.
okay, yeah. So I subtract 4 from both sides. This goes to 0, 1 left. Subtract 0.2 from both sides. This goes to 0.2, this goes to 0.
Well, okay, yeah, I guess that works. Okay. And then let's see, x equals 5.
X equals 5. Okay, so this is the second box. The question asks how many pounds of cashew are now in this new mix? How do we find the amount of cashew?
You just do 0.4 times 5.
Okay, so that will be the cashew from the second mix. What
And
about the
then-
first one?
Yeah, and then you add 2 from the first.
Okay, so we put them together, we get total cashew.
I believe that's a 4, I believe.
So it will be C1 plus C2. C1 is 2, C2 is 0.4, and x is 5. Okay, that's right. We get a 4. So the answer will be B. Okay. So you can see for this one, we use the information given in the problem. We found the amount of peanut, cashew, almond in the first box. Second box, we don't know what it is. We assume it's x. We find the formula expression for the peanuts, cashew, almond in the second box. Now, if we add the first part, second part, this will be the peanuts in the new mix. Then the information. In this new mix, the peanuts is 40%. We have this from equation. We solve this equation, we get x. That's the weight of the second mix. Now we have first cashew, second cashew, add them together, we get the total cashew. The number is B. Any questions? Okay. Okay. Let's try the next one. How many isosceles triangles are there with positive area, whose side lengths are all positive, with longest side at length 20, 25?
Can I take a guess?
Okay. Which which number you guess? Okay.
I'm guessing B or E.
You guess B or E?
Wait, is
Based
it
on what?
or E?
Based on intuition.
Okay. Aaron, what's your idea?
Well, let's see. I forgot to do this question because like I skipped it by accident, but I'm just gonna guess A or E.
Okay. Two guesses. Jessica, what about you?
Um, um,
Were you chatting with your friends or what were you busy with?
not really. I think I was like zoning out.
Okay. So let me first draw a picture.
Wait, so it can be like 2 of the sides are 2025 too, right?
That's possible.
Yeah.
Oh, 25. What's this side can be? Could be 0?
No.
No, because it has to be positive.
Larger.
So
Yeah.
the smallest is
Anything.
the 1.
Yeah.
What's the largest?
I'm blanking out.
Okay, could we go 3,000? Is that allowed?
Yeah,
Could be
maybe.
3,000.
Yeah.
Okay, let's check. The question, whose longest side have,
Oh, okay. I forgot about that part.
okay,
So
so
the
that's,
longest is
uh,
2025.
so how long could this go?
Until 2025, I think.
Okay, let me check. Okay, so be careful about the last one. The last one, when x is 2025, what's the shape of this triangle?
It's equilateral.
Equilateral. So sometimes this is not considered as isosceles. Sometimes it is, sometimes it is not. So you should be careful.
Okay.
It depends. So this one we put a question mark here. We'll get
Mhm.
back to check this later. Okay. The next possibility, still isosceles.
And then the longest side is the one side is 2025 and the other two are like x.
X. Could x be 1?
No.
Why?
'Cause the two added together
Okay.
aren't greater than 2025.
Yes. So for this to be a triangle, the addition of these two must be greater than this. Or we can say x is bigger than half of 2025.
Mhm.
X should be bigger than. Simplify, we get okay. So for this to be integers, we will start from 2013. Okay, what's the largest number?
Also
Take a wild
2025
guess, but like
if
1,000
if
to
they count
800.
that as an isosceles.
Okay, so what Amy said is this can go as long as this one because this one is the longest.
Uh-huh.
Okay. Now we should be careful again when the is 2025, we get the same equilateral. We should check whether this is counted or not, but we cannot count it twice. Since if we count it here, we will drop this one there. We cannot count it twice.
Now I think it's B
It's B. How do you get B?
because well, since my brain thinks it makes sense that they would put 2025 as an answer, when you have one, like if you count an equilateral as an isosceles, that's the one extra possibility. And then if you just like add the one to 2025, that's 2026.
Okay, now let's check. We have two collections, Amy. The first collection here, second collection here. How many do we have over there?
A lot.
Okay, it's from 1 to 2025, so that will be 2025. And they are different. They're
Oh,
different.
okay. Never mind, it's not B then.
Okay, definitely not a B because only this part is almost there. We have
Oh,
quite a lot over there.
it's C,
Okay,
right?
let's check. Let's check.
Are you guessing?
Wait, no, D. I meant D. I meant D. I didn't mean C. I mixed
You're
the two up. I
guessing?
meant D.
Let me guess, you're guessing.
Okay, why?
Well, it's basically 2025 plus 1012, but still.
Uh-huh. So
But you should count the 0.5 in that answer too, because like
the difference here will be okay. Now we add them. What do we get?
3037.
We get a D. Okay, that's what Amy checked. Okay.
Yay.
Okay, now we know how to count. We put this into two collections. First collection, the two legs are long, the base is short, but the base changes from 1 to 125. Second collection, the base is long, but the legs are short. But it cannot be arbitrarily short. It must be at least half of the base. Okay. One more
Hold on, let me write
question.
this down. Let me write this down.
Okay. So, team, Jessica, focus. Students
I have
going
a
to
question.
compete. Yes, Amy.
When you said last question, do you mean like, are we gonna do number 5?
After break. So we will do
Oh,
this
okay,
one,
okay.
have a break, then we'll continue.
Because I think I solved number 5, so I was, yeah.
Okay, you will have a chance to present it. Okay. Number 4. A team of students is going to compete against a team of teachers. The total number of students and teachers is 15. Okay, that's the total. Ash, a cousin of one of the students, wanted to join the contest. If Ash played with the student, then the average age of the student team will increase from 12 to 14. If Ash played with the teachers, average age of the teachers team will decrease from 55 to 52. How old is Ash?
29,
Okay. How do you get that?
I guessed.
You guess.
Did I guess right?
I cannot tell. Let's think
I
about
think
it.
that's a yes.
Okay. You think it is yes. Okay. You.
Because if you're like a cousin who's old enough to decide whether they want to be young or old, I think 29 is a good age.
Okay. Let's start with the equations. We'll set up the equations. So total is 15. Now, first question, what's the number of students? The number of teachers? We don't
There's
know.
15 in total.
So 15 in total. So let's assume the students number S,
S plus
teacher
T equals 15.
number T. So students plus teachers
Equals 15.
is 15.
It's like a
Okay, that's
system
our
of functions.
first equation. Okay, so you can see when we solve this problem, we will translate sentence by sentence from descriptions to mathematical equations. We convert everything to mathematical equations. Another one, Ash. We don't know the age of Ash, so let's assume X, the age. Okay, if Ash plays with the students, the average age of that team will increase from 12 to 14. Okay, how do we convert this to a mathematical equation? Okay, let me draw a picture. So initially, we have a group of
Wait, I
students.
think I know.
Okay, yes, Amy.
I think it's, wait, I think I just forgot. I think it's something like, uh, S, wait, no. 12 plus X divided by S equals 14, right?
Okay. Okay. So let's almost as in the correct direction, but let's make some changes. Initially, we have S student. If Ashley play with the student,
Oh, okay, S plus 1.
okay,
Right.
that's the first correction, S plus 1. Second correction, the average age of the student is 12. So what's the total age of student?
12S.
12S. So here it'd be 12S. Okay, very good. Okay, this is our first equation. The next one, or maybe the second equation. If Ashley plays with the teachers, the average age of that team will decrease from 55 to 52. I will ask Aaron, can you give me an equation to represent this fact?
Hold on, I'm currently adding. Hold on.
Okay. Hint, it will be similar.
Yeah, I know. It's like
Okay.
55t plus x over t plus 1 equals 52, I think.
Yes, perfect. 55. Oh,
Over like t plus 1 equals 52.
all right. Okay, now we
It's a
have
system of functions, I believe.
we
But
have okay, first, before we move on, we have three S, T, X, three unknowns, and three equations. So three unknowns, three equations, normally we can solve S, T, and X from them. Okay, it's not easy to solve this directly, but let's first simplify this. We don't like denominators. So I will multiply both sides by S plus 1. Let's get rid of the denominator.
so that's like 12s plus x equals 14s plus 14. And then for the other one, it's like 55t plus x equals 52t plus 52.
Okay, you are very quick. I cannot catch up with you. Oh, 52, I copied wrong. Be careful. 52. All right, let's do simplifications.
We can do some subtraction.
Okay, subtraction. 12s, 14s. What do we have?
That would be x equals 2s plus 14, I believe.
X equals
And for the other
2s.
one, it would be like 52 equals 3t plus x.
Okay, so 3t plus x
Although
is
in contradiction, you could just say x equals negative 3t plus 52.
okay. It's the same, right?
Yeah.
Okay.
But it's better if we do x equals negative 3t plus 52, because that way you can just plug it in.
Okay, I could. Let me think what I should do. I have. Okay, so let me do what you said. X equal negative 3t 52. Okay, so these two equations, they both give us x. In particular, these two sides must be the same.
Mm-hmm.
Okay, so we have a new equation. This and
2s plus
this.
14 equals negative 3t plus 52.
So 2s plus 4t. 3t plus 52. Okay, simplify. I will add 3t on both sides. I will subtract 14 from both sides. The 52 I copied wrong. So always double check. It's very common we copy something wrong, so it's always double check. will be 38.
And
Okay.
then,
Yes, Amy.
and then you can use the first equation we made.
Mm-hmm.
And then you can either do t equals 15 minus s or s equals 15 minus t. I think we'll
Okay.
do s equals 15 minus,
Okay.
right?
So 215 minus t. We simplify, we get 30 plus t equals 38. Okay, what can I see from here?
And then so we
Just
can
do the two
say
combinations.
t equals 8.
T equals 8. T equals 8.
And
Is
s equals 7.
what?
Aaron, what's that, Aaron?
If t equals 8, then s equals 7, because like something plus 8 equals 15.
Did we do
S
something
equal.
wrong?
What's x?
Wait, where's x again? Oh, let me see now. X equals, well, 28.
Amy, do you get 28?
No, I got 29.
No, it's true. So if you plug in t on the x equals negative 3t plus 52, that would be x equals negative 24 plus 52, which equals 28. And if you plug in s on the s side, you could equal 14 plus 14, which is 28.
And that was a close guess though. I was one away.
Okay, okay. So now we can not only guess, but the steps is when we read each sentence, you try to write down a mathematical formula for it. A mathematical formula for it. Then from this word problem to this mathematical problem, we solve the equations. Okay, let's have 5 minutes break. We will be back at 8:28.
Okay.
Okay. Okay, Amy, you mentioned you have some thought on number 5. Where do we start?
Well, my answer was E.
Okay, how do you get this answer?
Okay, so first off of the pattern, I actually kind of represented it visually.
Mm-hmm.
Like, hold on, I need to show you the paper. Wait, no, never mind. It's like uh the climax almost of each like number. So basically 2, 1, 2, 1 is like the first section. And then 1, 2, 3, 2, 1 is the second section. Like one number always ends up overlapping. And then
Mm-hmm.
so on and so on, right? So 2, 3, uh that one, yeah, those ones, 4 and 5
Mm-hmm.
are like the second term, fifth term, 10th term, 17th term, 26th term, and so on. The 26th
Okay.
term is for 6, but they didn't list 6 on there. Um, and if you notice, if you go back one number, like the 1 is the first term, uh the 3 is the fourth term. Wait, the first 3 is the fourth term. This wait, no. The 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 second 3 is the ninth term. The second 4 is the 16th term. So that's one back from like the highest number. Do you get what I mean?
I mean, so you said this one
Yeah,
is the
ninth.
three ninth. Okay.
Yeah.
And this
And then
is
the the
16th.
2, yeah, yeah. And
Okay.
then so you can tell that it's just the square, like
Mm-hmm.
4 is the square root of 16. And then in
Mhm.
the um problem it asks what is the 2025 fifth term in this sequence. 2025 is the square of 45.
Okay, that's very
So
nice.
that's where you get 45.
Okay, I see. Let's see.
It could be wrong because
Mhm.
I don't know, but I think it's 45. I think.
Okay. Uh, so what Amy's observation is every squared position, Okay. So this is 3 is the 9th position. This 14 is 4. Let's count 10, 11, 12, 13, 14, 15, 16 position. Okay, let me try to go a little bit further. 3, 4, 5, 6, 8, 9. Oh, not. Let's stop at
6,
6.
5, 4, 3, 2, 1.
Okay, yes. 5, 4, 3, 2, 1. Let's count this 5, 17, 18, 19, 20, 21, 22, 23, 24, 25. Again, square. Okay, so she observed that each squared position is the square root. So in particular, this is a square. So her observed that should be E. Okay, very nice, very nice. Okay, so E. We can also add you can add first, fourth, also works. Okay. Okay, let's see, how do we verify this? Is this easy to verify? Let me just think about it. Okay, maybe it's possible to verify this, but the shortage of this approach, Amy, the last year, 2025, what about in 10 years, another 10 years, 2035? It's not a square, what should we do?
It's like 10 away from
Uh-huh.
the
Okay, so
2025th term, so you just add 10, I think.
you follow the pattern. So there will be 46, 45, you go 10 more steps.
Yeah.
Okay. Okay, so that works. Okay, let's go to that's correct. Let's go to number 6. Number 6. In an equilateral triangle, okay, let me first draw an equilateral triangle. Okay, I will adjust it, make it think it's about right. Equilateral triangle. Let me use my ruler. A, B, C. Okay, that's the first sentence. First part of the first sentence. Equilateral triangle. Each interior angle is trisect by a pair of rays. So we will divide this into three small angles with two rays. One, two. This one. Two. And this one. Oops. Let's see.
Why does it look like a stars?
Well, it's not. Maybe
Because it
my
kind of, I know it has like six sides, but it just looks like it.
okay, my drawing is not perfect, but it's kind of approximated correct. Okay, that's the trisected by pair of rays for all interior angles. The intersection of the interiors is a convex hexagon, so it's this one. I will use red color. Let me check if I can. Okay, I could adjust this a little bit more.
Wait, I'm kind of confused.
Okay, yes. Okay, Amy,
It
which part?
says it
Mhm.
says that what is the degree measure of the smallest angle in this hexagon? But if it's like this hexagon, shouldn't all the angles be like equal?
Well, that's the
Or
point. So here we don't know if it's regular or not. It's a general hexagon.
okay,
It's not a regular hexagon.
I see.
Okay, so let's check. Let's find these two angles, this one and this one, and check which one is bigger, which one is small, or are they the same? Okay, we start with this one. Uh, how do we find this angle? We can use one property that the vertical angles have the same measure. Could we find this one?
Well, yeah, I think those are equal, I believe, because they're on the same vertex.
Okay. So we want to find this angle. We start with this one. But this one we have a quadrilateral. Let me draw the quadrilateral.
Oh my God. I just realized um the other four squares, if you combine them, it's like basically the exact same thing from the homework problem.
What?
If you like
Okay.
trace all the way up, that's really scary. I didn't like that homework problem very much.
Which homework problem? Which
A
one?
lot.
The optional one.
Okay, cyclic quadrilateral.
Yeah.
We have 5 or 6 cyclic quadrilaterals.
Oh dear. I see what you see now. Why do they all look so kind of...
Okay, so next step by step. Okay, what's the total angle of this quadrilateral?
That'd be like 180.
360.
Oh yeah. Wait, what? Oh yeah, 360. Yes, yes.
Okay, so
I
total
assumed it was
angle
like one line.
360. What's this angle?
Um,
That's
90.
like
Wait, no. What
that's
what
like
am I thinking?
60 or
60,
something.
60.
Because it's
Okay,
equilateral.
so we have this angle 60. Okay, a difficult part. How to find this angle? This angle. These two angles are the same, but what are they? How do we find these two angles?
I believe that since they're on the same line, then that angle will be 120. Because they're on the same line.
Same line.
Yeah, like it's that theorem. Uh, what's it called? The theorem, a co-interior angle, something like that.
Okay,
No,
let's
that would be for parallel.
Oh yeah, but like still, but since they're on the same line and that one's been bisected, then that's still
okay, I'm going to draw another triangle. I will ask you. Let's check this triangle. Let's check what color I'm going to use. Okay, this one.
oh,
Okay, in this triangle, what's the total angle?
180.
180. And this angle we know it's 60.
Yeah, so the other two angles
What?
are 120.
So this angle is 20. What is the angle left over there?
That's like 100.
Okay, any do you agree? Is it 100? Okay, so that means this will be 100. In the same way, this is 100. This is 60. Okay, what is this angle? The leftover.
One 100, right?
Okay, so this is, how do you get that, Amy?
Because the total is 360, so it's just 360 minus 260.
Okay, so subtract 60, subtract 100, another 100 equals 100. Okay, so we get a progress. This angle turns out to be 100 degrees. Okay. What about this one?
That will be the same as its vertical angle, which is right below it,
Okay,
and
nice.
it's an isosceles because there's 20 on the other sides,
Okay, so
right?
two
So
20s.
yeah,
Uh-huh.
20 plus 20 is 40, and then 180 minus 40 is 140. So that one's 140.
Okay, so this 180 subtract 20, subtract another 20, 140. Okay, now Amy, you find out the two angles are different.
Mm-hmm.
What's the smaller angle?
100.
Now, okay, this is 100.
I see.
Okay, so here another thing is it's because we have the symmetry, these two angles the same. We have three 100 and three 140. Okay, so 100 is the smallest. Okay, number 7. A and B are real numbers. The polynomial is divided by x minus 1. The remainder
I
is
hate
4.
these problems.
What's that, Amy?
You hate
I don't like these problems. I've
Okay,
done them
these
before.
in
problems
the
are like
end,
kind of like
you will like this very much because it's very
kind of
interesting
simple actually.
solution. Aaron, what's that, Aaron?
Let's just see. You just put the polynomial. Hold on. Hold on, wait a second.
Okay, again,
What's going
let's
on?
practice. How do we convert this to a mathematical formula? When a polynomial is divided by this, the remainder is 4. So, mhm.
You basically put it as a fraction, I think, and then equals the solution plus 4.
Okay, so for simplicity, I'm going to call this polynomial our function fx.
Wait, you could just put that polynomial into something like x times x plus b and then x plus 1 because there's nothing that b could be divided by.
Okay. So step by step, fx is divided by x plus 1, x minus 1. We will have a quotient and remainder. Here, the
Plus
remainder is
4.
4. Okay, let's do the same thing for the second sentence. Write down a formula for the
So
second sentence.
that's fx equals x minus 2 qx plus 6, I believe.
X minus 2. So here it could be a different quotient. I will
Well,
use
okay, you could just put in,
px
yeah.
plus 6. Okay, a special case. For the first one, what happens if x is 1? Amy,
What?
what's f1? Unmute.
Oh, okay. So the first in parentheses is 0,
Mm-hmm.
and then q, since x is 1 plus 4.
I think it's q plus
So
4.
it's just, huh? Yeah, wait. Yeah, wait, no. Because the first one is 0. So it's
Okay,
just 0 plus
and
4.
okay, nice. Aaron, what's the second one? F2.
I believe that should be f2. Okay. That's still 0 times 0, and then, I mean, yeah, but it would be 2, but since 0 times p is like 0, then that's just 6.
6. Okay, now let's use the information. Fx is this. So use this, find what's f1.
Well, that's just gonna be like 2 plus A plus B.
Okay, so we have our first equation. 2 plus A plus B is 4.
Well, yeah, so you could say A plus B equals 2.
Okay, let's do that. I will give you a few minutes to try the second one. Could you get a similar like this? This is our function. What is f2?
Okay, let's see. Let me. Oh wait, oh yeah.
Jessica, do the work.
I've got it.
Okay, Aaron.
It's 12 plus 2A plus B.
12 plus 2A plus B equals
6.
6.
Then 2A plus B equals 6. And then A plus B equals 3.
2A plus B equals
Oh, hold on, wait, no. It's -6. Whoops. Sorry.
negative 6.
I just
Okay,
subtracted from the wrong side.
okay. So now
And then
we
you
have
could just say, or you could just say like A plus half B equals -3 if that works.
okay, we could, but let's do the subtraction.
Oh,
Uh,
okay.
we subtract.
Wait, are they equal F1 and F2?
What do you mean they are equal?
Like,
F1 is 4, F2 is 6.
uh-huh. Oh, wait, okay.
Okay. So from here, what is B?
B equals A minus 2.
Aaron, double check.
Wait, no, wait. Sorry, I meant 2 minus A. Sorry.
Okay,
Sorry.
so
Said
we
the wrong
will
order.
substitute B by 2 minus A.
So that would be 2A plus 2 minus A, which equals A plus, whoops. I meant, yeah.
What's A?
A is, let me see now, -8.
What is B? Negative 8. Sorry, let me correct this.
B is 10, I believe, because, yeah.
2 minus A, which is 10. Okay, now what is B minus A?
Uh, 18. Because it's 10 minus -8, which equals 10 plus 8, which is 18.
Okay, very nice. Now, Amy, what do you think of this problem?
It's a very interesting problem indeed, but I still do not like it because it involves functions.
Okay.
Okay, that's just kind of offensive to math.
Yeah,
Because I love functions.
So here, again, we translate this to an equation. The polynomial divided by this, we have the divisor, the quotient, and the remainder. Property of this that when x is 1, this term goes away. Only the remainder left. So we have an equation. The second condition gives us a second equation. Now, two equations, two unknowns, we can solve them one by one.
I both hate and respect the people who come up with these problems.
Probably the really intelligent mathematicians.
Yeah. I mean, it's so
But,
hard. It's like reverse solving it, and
well, it has
you
to
have
be
to
born in
look
the
for
mind of
something
someone.
that fits perfectly. But it's also really annoying when you're the one solving them.
Actually, this one's
Okay,
kind of light work. This one's kind of light work. So.
okay, the eighth question. It's a little bit tricky. Jessica, read this question.
Wait,
What is this?
did you ask me to read it?
No, okay,
Oh,
just check. Okay,
what?
what does it ask?
Oh, at least
Huh?
one. Wait, what?
Wait, what?
Wait, was
Oh my
yeah,
God. This is like the lying, like, like the liar's paradox thingy. That
Kind
thing.
of, kind of.
Yeah.
So the
Liar's paradox? What's that?
Annie, she writes the following four statements. Okay, the first statement, at least one of these four statements is true. Second, at least two of the statements are true.
Wait, that's basically four statements. Did you write those four statements? That's
So
saying,
there's four statements.
yeah.
Each is a
It's a
judgment
paradox. I see
of the
now.
four.
I can see the
Yes.
paradox here already.
Yeah.
So it's a judgment on itself.
Yeah, I can
At
really see the
least
paradox.
two of these are false. At least one of these is false.
Just say
Okay.
two of these are false, and that'll be simple. Because it's a
Each statement
paradox.
either true or false. How many false statements do we have?
Okay, we know it can't be E.
It
Well, yeah,
can't be.
obviously.
Let's
Why it
just
cannot be
eliminate
E?
them.
Okay,
And it can't
Amy,
be
why?
three either, because it said only at least two of these statements are false.
Mm-hmm.
So it can't be three either. And it can't be zero either, because there's no zero false statements here, because there already is one false.
Okay, step by step. Suppose they are all false. Do we get contradictions? Get paradoxes? Okay,
Yeah.
Amy, you say yes. Where?
So if you say at least two of these statements are false,
Uh-huh.
then okay, that I can't explain these things.
Okay, let me help you.
Yeah.
If all four are false, well, let's check this one. Either this one true or false.
That means one of these statements is true. And it's
Yeah.
like negative.
Okay, we started with the assumption that all four are false, but now this one is turned out to be true. It cannot be
And
true
it also
false.
contradicts to 3 too, because it says that if three of these statements are false, then two of these statements are, etc.
Okay, so there are a lot of contradictions. At least we can eliminate this.
Mm-hmm.
Okay, second, let's try this. Could they be all true? Do we get the contradictions?
No,
No, because
Why?
it says at least one of these statements is false.
Yeah.
So it can't be all true. It's literally just a
Okay,
paradox.
because if they are all true, this turns out to be false. Okay, so it's the statement say something is true. This statement is false. Okay, if it's A, okay, could we have two?
I
Could be.
think so. Wait, let me check.
Which two are true? Which two are false?
First
The
two are
last
true,
two
first two.
would be
Okay, let Amy finish. Which two are true?
the first two, I think.
First two are true. These two are false. Okay, let's check. Okay, Amy. This statement under your classification, true or false? The last one.
Uh, eh,
True or false?
okay, then it's probably not C.
Okay. If this is false, these two are false, then this one is true. Contradiction.
Mm-hmm.
Okay, not C.
It's
Okay,
either
I will
one or
not
two.
tell you what the answer is. We'll continue from here next time.
What?
What? You're not gonna
No.
tell us the answer? So we don't do
Okay.
this ourselves? Seriously?
Okay, so only two
It's B
Choice
or
is left.
D. I'm going with D. I'm going with D. I'm going with D. I have faith in the false.
Okay. Okay, let's try. Let's say maybe 1 minute we have finished. If
Okay.
you have 3 false statement, only one is true. Which one is true?
Then it would be
I think it's B.
Okay, Amy has another one. Okay.
I have faith in D.
Okay. Amy, what's the argument for B?
Mm, mm,
Well, okay, there are two reasons actually. The second reason is like actually by looking at the problem, it's not me guessing. Because I didn't completely think it thoroughly, but it makes somewhat sense to me.
Uh-huh.
And the other like non-mathematical reason is because my physics test was basically all B's the other day, and I think it was a sign from the
Hey,
universe.
Okay.
you
Okay.
got physics in your class?
I have, yeah, I take physics
Okay.
class.
So B is the correct answer.
Yes, I knew my physics teacher was trying to tell me
Okay.
something.
Now you have to tell me which one of the 4 is false.
Oh dear.
Which one is
eh,
false? Okay, there's only one. I tell you
I think
this.
it's the last
third
one. One of
one.
these statements is false because it's already
The
worked.
third one.
Okay.
It's probably
This one is false.
Yeah, I knew it. I was right.
Okay.
And you
So
know, sorry,
yes.
I was that was the other sign from the universe. Because you see, my physics test was all B's, and then there was one answer that was C.
Okay. Okay. So we will stop here, but after class, you should convince yourself there is no paradox in this setting.
Okay.
All statements are what they need to be. Okay, we stop here today. Any more
okay.
questions?
That was
Okay,
just really
okay.